Hello. So yesterday we worked on how to write equations from word problems, and so today we want to be able to solve those equations. And I think it helps when you know where they're coming from, because you can kind of think about how to work backwards to solve the equation, and that's how you would have solved the problem to begin with. So the steps to doing this, if you want to think of them as steps instead of thinking backwards, first thing I want to do is draw a line down from the equal sign to separate the two sides of your equation. So what that looks like is I come to my equal sign and I'm going to draw a line down right there. Now whatever is done to one side of the equation must be done to the other side to keep it equal or balanced. So for instance, on this first one, I'm going to want to do the inverse operation of what I'm looking at and reverse order of operations. So I've got 5 times x plus 26. Order of operations would tell me to multiply before I can add, but I'm going to do the opposite or inverse of that in order to solve it. And then also the inverse sign, if I'm adding 26, I want to subtract 26. And the reason I'm doing this is I want to get my variable and I want to isolate or get my variable all by itself, meaning I just want x, not 5x, not x divided by 2, I want just x. So if I do to one side, if I do negative 26 or minus 26, I'm going to do the same thing to the other side. Positive 26 and negative 26 are additive inverses, so they equal 0, which means they cancel out. Now what I still have is this 5x. Over here I've got 46 minus 26 and I get 20. And my last step to solving this equation, reverse order of operations, I'm multiplying. The inverse multiplication is division, and you want to get used to seeing your division as a fraction. That's how you're going to see it. You're not going to see a little division sign anymore. So as a fraction, 5 divided by 5 is 1. So this equals 1x. We usually just write it as just x. And then 20 divided by 5 is 4. Now the last step is you want to check your answer by plugging it back into the equation. So if this is my original equation right here, I'm going to take my 4 and I'm going to plug it right in there where that x was. So 5 times 4 plus 26 equals 46. So 5 times 4 is 20 plus 26. And 20 plus 26 does equal 46. And 46 equals 46. If I end up with the same thing on both sides of my equation, then I know I've got the right answer. Sometimes you see it with the variable written on the other side. Now if that really bothers you, you can move it over. All you got to do is write the equal sign on this side and then the negative 11 over there. And then it's like that's gone and it looks just like the equation above for the most part. So if you prefer to keep it on the left, you are more than welcome to take that out or write it on the other side and solve it that way. I'm just going to show you what it looks like though to solve it on the other side here. I'm going to follow the same steps. I'm going to draw my line down from my equal sign. I find my variable. I need to get this letter b all by itself, my variable. Well, right now it's being multiplied by negative 5 and then it's having 6 taken away. So instead of having 6 taken away, we're going to add 6. Now whatever I did to this side, I need to do to the other side as well. These are additive inverses, so they cancel out. Now what I still have is that negative 5 times my variable, negative 5b. And over here I've got negative 11 plus 6, which is negative 5. The last thing I need to do then is I need to divide by negative 5. Negative 5 divided by negative 5 is positive 1. So when it's a negative coefficient, I need to divide by a negative or multiply by a negative, depending on what's going on. Over here you'll see we'll end up needing to multiply by a negative. I need to get rid of that negative so that my variable becomes, I just want one positive b. I don't want any negative b's. I don't want the opposite of b. I want the b itself. Negative 5 divided by negative 5 is also 1 over here. Just happened to work out that time. When I go and I plug this back in, and you can think of that as adding a negative if you want, but I'm sure that you can look at that and just say, oh, if it's negative and I'm subtracting, I'm going to continue to go down on the number line. Negative 11 equals negative 11, so indeed I did find the right answer. Down here we've got one very similar. I'm going to have a fraction in this one in front of the variable. I'm going to show you how to handle that. So I'm going to draw a line down from my equal sign. I'm going to add 5 because that is a negative 5. I'm taking 5 away from whatever this multiplication problem is. So I need to add 5. And I want to do that to both sides. So my negative 5 and my positive 5 are going to cancel each other out. I still have 3/5 of whatever a is. So I don't even want one whole a. I'm just taking a part of an a. So 10 plus 5 is 15. Now what I'm going to do is I am going to multiply. You're like, but it's already multiplication, Mrs. Williams. But I'm still going to multiply by its reciprocal. Because if you recall, if I take a fraction and I multiply it by its reciprocal, actually any number multiplied by its reciprocal, I'm going to get positive 1. And that's what we're looking for. 5 times 3 is 15. 3 times 5 is 15. 15 over 15 would be 1. I can also think of cross-canceling, and I would get 1s in all those places and just have a left, or 1a. We just don't typically write the 1a. Now, if I multiplied by 5/3 over there, I need to multiply by 5/3 over here as well. Any number can be a fraction. Just put a 1 under it. I can cross-reduce again. 5 times 5 is 25 over 1, so a is 25. So 3/5 of 25 minus 5 should equal 10 is what we're looking at here. So negative 5 plus 3/5 a equals 10. And I'm going to go ahead and write my 25 as 25 over 1. Just went ahead and made my fraction into my whole number into a fraction by putting a 1 under it. I'm going to go ahead and start here. 3 times 5 is 15, and you can think of that as being over 1, but anything over 1 is just itself. And 10, again, does equal 10. Back up here, you'll notice we have fractions going on in all these equations on this side. Well, every fraction is a division problem. It is another way to write a division problem. And so all we're going to do to undo division at the end there is instead of dividing like we did over here, dividing by 5, we are going to multiply by whatever number is on the bottom. So I'm still going to draw my line down. I'm subtracting 14, so I'm going to add 14. Those cancel out. I still have some number divided by 3 is now equal to 15. And I'm down to a one-step problem. So like I said, I'm dividing by 3. I want to do the opposite of that. So I'm going to multiply by 3. And once again, you can think of that as 3 over 1. These 3's will cancel each other out down to 1. So I end up with just n equaling 45. When I go to check it, I do indeed get that it's the right answer. One quick thing, if I put the wrong answer in there, say I thought n was 50. So if I were to put 50 in there, let's put 60, because that'll be a nice division problem there. So I would get 20 minus 14, and then I would get 6 equals 1. I'd be like, oh, guess what? 60 was not the right answer. So I would need to start over. So if you're checking it and you don't get the same number on each side of the equal sign, you've done something wrong. Once again, over here I've got something that I'm dividing my mystery number by. Happens to be negative this time, so that just means at the end we'll multiply by negative. I'm going to start the same. I'm going to drop the line. I'm going to subtract 8 from both sides. Additive inverses cancel out. So now I have y over negative 7. So some number divided by negative 7 equals 11. I'm going to multiply, and if it's negative, I'm multiplying by negative. Because once again, I want to get rid of the negatives and have just a positive y. Now the answer to y might be negative, but the y itself is positive. There's no negative sign next to it. So when I come in over here and I plug that in, remember, a negative divided by negative is positive. I do indeed get that it worked out. Now, possibly one of the scariest looking problems here is this one. And just with every rule in life, it feels like there's going to be one exception. So we say do the inverse order of operations. And you're like, Mrs. Williams, I should be subtracting 5. But you see how it's stuck up in the numerator. So we have to get it out of there. So in order to get rid of this fraction, one way that you can solve any problem that comes up with a fraction like this, you're like, ooh, I want to get rid of the fractions. Fractions scare me. I don't want to look at fractions. I can take whatever the denominator is and multiply the entire problem by that. And that's exactly what we're going to do here. I'm going to go ahead and drop that line. I'm going to multiply both sides by negative 3. So as long as I do the same thing to both sides, I can get rid of that fraction. So these cancel out to 1s, and then I'll have 4x plus 5 over 1. But anything divided by 1 is itself, including this expression. So that's really just 4x plus 5. And over here we've got negative 7 times negative 3, which is just positive 21. Now I'm going to subtract 5 from both sides. Additive inverses cancel out. I bring down the 4x, divide by 4, and I get x equals 4. When I come back over here to check out if that is actually my answer and make sure I am correct, 4 times 4 plus 5 divided by negative 3, will that equal negative 7? Well, on top we get 16 plus 5 divided by negative 3, so we get 21 divided by negative 3. And I can see that that's going to be negative 7 is equal to negative 7. And indeed, our answer checked out there. Last problem, we're almost there. The perimeter of a rectangle. So I have my rectangle, and it tells me that the perimeter of that rectangle is 31.8 centimeters. And then it tells me that the length is 8.9 centimeters. Well, to find the perimeter, I do 2 times whatever the width is, because a rectangle, they would be the same, and 2 times whatever the length is, because once again, a rectangle, they would be the same, equals 31.8. I don't know what my width is. It's what I'm trying to find, but I can plug in 8.9 for the length. So I'm going to end up with 2w plus 2 times 8.9 equals 31.8. So first I'm going to need to do 2 times 8.9 and get 17.8. So now 2 times the width plus my 2 lengths together, which is where that 17.8 comes from, equals my perimeter. I'm going to subtract. That cancels down to a 0. And I'm subtracting that as well. So I need to borrow. So I get 14. So 2 times something equals 14. I'm going to divide by 2. And I'm going to find that w equals 7. So my equation again was 2w plus 2 times 8.9 equals 31.8, and I found out that my width was 7 centimeters. Feel free to pause this, stop it, go back, re-listen to it, try to figure it out before you see the answer, all to try to help yourself, and let me know if you have any questions.